You know that device you're watching this on right now? It really does feel like magic, doesn't it? But it's not. It's an incredible machine with a really fascinating story. So today, we're going to metaphorically unbox that machine, take a look inside, and figure out how a computer really works, from the silicon chips all the way to your clicks. All right, here's our game plan. First up, we're going to meet the physical team inside your machine, the core components. Then we'll track down the ghost that tells them what to do. After that, we'll get into the digital language they all speak, see how they manage to shrink from the size of a room to fitting in your pocket, and finally, we'll put it all together and watch it work in real time. So, let's start with the hardware, the physical parts you could actually hold in your hand. This is the foundation, the nuts and bolts of, well, everything. You know, at its very heart, any computer, whether it's a massive supercomputer or just the calculator on your phone, really only does three things. It takes in information, we call that input. It thinks about it, that's the processing part, and then it gives you a result, the output. Sounds simple, right? But the real magic, the secret sauce, is in how it does that processing. Okay, to really wrap our heads around this, let's use an analogy. Imagine your computer is a super sophisticated high-tech workshop. It's packed with specialized workers in different areas, all working together for one single purpose: to get jobs done at lightning speed. So, who's the star of this workshop? That would be the CPU, our master craftsman. This thing is the absolute brain of the operation. Every single instruction, every calculation, from you opening a file to some really complex video editing, it all goes through the CPU. It's the one doing all the heavy lifting. Of course, even a master craftsman needs a place to work, right? And that place is the RAM. Think of it like a big workbench sitting right next to the craftsman. It holds all the tools and materials for whatever jobs are happening right now. It's incredibly fast, which is crucial. But here's the catch. When you turn the power off, that workbench gets wiped completely clean. So if the workbench is only temporary, where does everything live permanently? Well, that would be in the warehouse, your storage drive. This is where all your programs, your documents, your photos are all kept safe and sound, even when the computer's off. It's way bigger than the workbench, but it is a little bit slower to retrieve things from. And that right there is the key difference to understand. RAM is all about speed for what's happening right now. It's that fast, temporary workbench. Storage, on the other hand, is all about safety for later, the permanent warehouse. You absolutely need both to have a workshop that's not only fast, but also reliable. Okay, let's keep building on this. We've got this incredible workshop full of powerful components, but how do they know what to build? What are they supposed to do? That brings us to the ghost in the machine, the software. I mean, that really is the critical question, isn't it? All this amazing hardware is just a silent collection of metal and silicon until it gets its marching orders. And those orders, the instructions that bring the whole thing to life, that's what we call software. Now, software isn't just one single thing. It really comes in two main flavors. First, you've got system software. Think of this as the workshop manager. The manager, your operating system, doesn't do a specific job itself. Instead, it manages all the hardware and makes sure everything is working together smoothly. Then you have application software. These are like the actual blueprints for specific jobs, like browsing the web or playing a game. This really shows you the clear chain of command inside our workshop. The operating system, the OS, is the boss. It's the only piece of software that talks directly to the hardware. All the other apps, they have to go through the OS to get anything done. That's why you can't run an app without an OS. It's like trying to start a job without the manager on site. It just doesn't work. Okay, so we've got our workshop and we've got our instructions. But what are we actually working with? What are the raw materials for all these jobs? Well, in the digital world, that one material is data. To a computer, literally everything is just data. This video, your music collection, an email, all of it. Sometimes that data is really neatly organized in rows and columns, kind of like a spreadsheet. We call that structured data. But honestly, most of the data in the world is messy, like a photo or a voice memo. That's unstructured. And a huge challenge in computing today is teaching our machines how to make sense of all that unstructured raw material. All right, now for what might be one of the most incredible stories in all of human history. How this workshop, which literally once filled an entire room, now fits comfortably inside our pockets.
This didn't just happen overnight. It started with mechanical gears back in the 1800s, then jumped to these massive room-sized machines that used fragile vacuum tubes in the 40s. The real game changer was the invention of the transistor in 1947, a tiny, super reliable electronic switch. Then, in the 70s, we figured out how to cram thousands, and eventually millions, of these transistors onto a single silicon chip. And that's when the workshop started to shrink, and shrink fast.
You know, this incredible shrinking process was actually predicted by Gordon Moore, one of the co-founders of Intel. His observation, which we now call Moore's Law, basically became the self-fulfilling prophecy and the engine that drove the entire tech industry for more than 50 years. More power, less space, and lower cost, year after year after year.
And the result of all this? Well, it's just staggering. Because of Moore's Law, a single chip inside your phone or your laptop today can have over 10 billion transistors. 10 billion tiny little switches, each one a small part of our workshop, all packed onto a surface that is smaller than your fingernail. It's truly mind-boggling when you stop and think about it.
So, we've met the hardware team, we've seen the software blueprints, we know about the raw data, and we've seen the incredible history. Now let's put it all together and trace exactly what happens in that split second right after you click on an icon.
And this is where it all comes together beautifully. That simple click, it sets off this rapid-fire, perfectly choreographed dance. Your click is the input. The OS, our manager, gets the signal and immediately goes to fetch the app's blueprint from the warehouse. That's your storage. It then copies that blueprint onto the workbench, your RAM, so that the master craftsman, the CPU, can read the instructions and get to work. And the final result, the output, is the app magically appearing on your screen. An entire workshop buzzing with activity, all in the blink of an eye.
From a calculator the size of a room to a global network that fits in our pockets, the evolution of this workshop has totally changed our world. And now, it's not just in our computers anymore. It's everywhere. It's in our cars, our watches, our refrigerators. So I guess the big question to leave you with is, with this unbelievable power at our fingertips, what do we build next? What new problems is this workshop going to solve? Now that is something to think about.